Let me tell you a story. It's 3 a.m. Your phone buzzes. Red is timeout in checkout. You have seen this before. You just can't remember the fix. You check Slack, you check dashboards, you gear up through logs. 45 minutes later, you find a pull request from 6 months ago that fixed this exact issue. But the engineer who wrote it, they left last month. Now, every observability stack has this problem. You have the data, logs, traces, metrics, but you don't have the memory. Every incident starts from scratch. Every investigation reinvents the wheel. So, this is Siggy. It's an AI powered incident investigation CLI that sits alongside Signos as a sidecar. It learns from every fix, builds a knowledge graph of your infrastructure, and returns explainable recommendations grounded in your operational history. So, Siki has six core capabilities. First one is vector memory that retrieves similar past incidents from quadrant, a knowledge graph that expands context through services, components, and failure types, an experience engine that ranks fixes by historical success rates, auto instrumentation that wraps any Python app with open telemetry, zero code changes, one command, explainable recommendations with root cause, fix, confidence, and evidence. Now, let me show you how it works end to end. So, your application sends traces to Signos via OpenTelemetry. When Signos detects an anomaly, an error spike, a latency jump, Siggy's sidecar picks it up. It is polling every 30 seconds via MCP. Now, the first thing that Siggy does is normalize the alert into a structured knowledge object. Um, this is a typed data object with fields like service name, component, failure type, symptoms, severity, root cause, and fix. The normalization has two paths: a deterministic regex first approach that handles hundreds of aliases, and an LLM powered path for everything else. System prefers the fast path and falls back gracefully. Then the knowledge object flows through three memory layers simultaneously. Layer 1 is vector search, quadrant. Now it converts the knowledge object into an embedding and searches for the most similar past incidents. It also supports metadata filtering by service, component, failure type, and severity. So you get semantically similar incidents from the same part of your infrastructure. Now, layer 2 is knowledge graph. This is an SQLite backed graph with 5 node types: service, component, failure type, recommendation, and operational pattern, connected by 7 relationship types. Now, when a Redis timeout hits the checkout service, the graph knows that checkouts depends on Redis, that Redis has failed with connection pool exhaustion before, and that the resolution was to increase the pool size. It expands context by traversing two hops from the failure node. Now, the layer 3 is experience engine. This is what makes recommendations improve over time. Every time an engineer records an outcome, this fix worked, this fix didn't, the experience engine updates its Bayesian model. It uses a prior of alpha equals 2, beta equals 2 to smooth success rates when data is sparse. The final ranking combines similarity score at 70% weight, metadata match at 30%, and experience multiplier that factors in success rate at 25%, resolution time at 10%, and confidence at 5%. The multiplier is clamped between zero point 0.8 and 1.2, so it nudges ranking without dominating them. Now, the final recommendation is explainable. It includes root cause, fix, confidence score, evidence chain, and reasoning. And it's written back to signals in three ways: as open telemetry attributes, so they show up in the traces explorer, into SQLite for persistent storage, and into a signals dashboard that Siggy auto creates on startup with 10 panels. So now let me show you the knowledge graph in more detail. Here is a concrete example: the checkout service. So it depends on Redis, and Redis fails with correction pool exhaustion. That failure is resolved by increasing the correction pool size. Each of these is a node in the graph. Five types: service, component, failure type, recommendation, and operational pattern, which I told you before. The edges are the relationships, depends on, fails with, resolved by, observed pattern, describes failure, etc. etc. When a new incident comes in, Siggy traverses this graph two hops deep to find related services, historical patterns, and prior fixes. This is how it knows that when checkout has a Redis problem, the session service and cache layer might also be affected. So now let me show you how it works on your machine. So I already installed Siggy on my machine. You can also install it like this: pip install Siggy-memory, and it will be installed in your machine. Now, okay, so let me wait till it installs. Okay, so Siggy-memory has been installed on my machine. So, so this is the command you type to start the Siggy on your computer. So when I enter this, the Siggy server starts. So if you are running this for the first time, it will ask for you your Grok API key and your Signos local API key, which you will type in the terminal itself. So let let us wait till it starts. Okay, so the Siggy server has been started. If we want to see the dashboard, we can go and check the local Signos dashboard, which is this. So let us wait for a second. So if we go into dashboards, so we can see there is a dashboard created by Siggy-memory layer. So every time you start up Siggy for the first time, it will create a dashboard like this with these panels for your ease. So yeah, it is fetching the data from the application. As we saw the demo, if we dive deep into what it actually does behind the curtains, we can see that there is a feedback loop running in Siggy. What it does is, whenever an alert fires, Siggy recommends a fix to it. Let's say engineer applies fix. So there can be two options: it worked or not. So let's say it worked and the resolution time was 9 minutes. So the Bayesian ranker updates success rate. It increases the success rate of that fix. Let's say if it did not work, then it updates that according to that. So the next time a higher confidence for this recommendation will be given if the success rate was increased, and it again goes for this Siggy recommends. So this is what the feedback loop